Hello dear students, today I am going to discuss with you a Pathfinder question, and the solution that I am going to present you is the simplest and the best solution that you can find on the internet. So let us move forward. Okay, so let us first analyze the question. A rod of mass m and length L is suspended from the ceiling with the help of two light strings so that the rod is horizontal. So we have a rod here, it is suspended by two strings. Okay, the rod is given an angular velocity omega about its central vertical axis. So this rod is given a angular velocity omega about its central vertical axis. Find the increment in tensile force in the cord immediately after the rod is given the angular velocity. So when it is just here and when it is given the angular velocity, what is the tension at that instant? What is the tension in the rod? Okay, so let us move forward. So first I'm going to show you different views of the rod so you can get you can understand what exactly we are doing. Okay, so first I'm going to show you the side view of the rod. Okay, so just look at the side view. If we give it a horizontal angular velocity, what happens? So you see the rod is going up, okay, then again coming down, then going up like this. Next, let us go on to another view. Okay, now the top view. So when you look at it from the top, it is going to be like this. Okay. Okay. Now there are few points which I want you to remember. Okay. See, what we are going to do is the rod is moving upwards. So when the rod was here, we are going to say that the vertical displacement of the rod is 0. So why is the vertical displacement of the rod, and when at this instant the y is going to be 0? We can say that the string is inextensible. So which means at this point, okay, when the rod is at the lowest position, it will not have any velocity, because if it would have had velocity, it would have had to go down, right? So if it goes down, it is not possible. Why? The reason being the strings are inextensible. So another point is, when the rod is at the bottommost position, its velocity, okay, its vertical velocity is 0. So two things I want you to remember. One, when it is the downmost position, y equal to 0. Two, when it is at the downmost position, the velocity, the upward velocity is also equal to 0. Yes, it does have an angular velocity. We are talking about the upward velocity. Okay, so let us move forward to the solution. So we are going to move forward in two steps. Okay, the first, see, the rod was simultaneously rotating and moving up. Okay, but what we are going to do is, in the first step, the rod is going to go from, just it is going to move vertically up. So this rod has moved vertically up. Next, so this is position 1, this is position 2, and in position 3, what we are doing is we are rotating it. Okay, similar to rolling, translation plus rotation, right? Here also translation plus rotation. Okay, and we will say that this going up is y. Okay, and from 2 to 3, this is x. Okay, see, this y and x is very small. This y and x is very small. Now what we are going to do is to find the tension, extra tension in this strings. See, two strings, no? So 2t equal to mass into acceleration. Okay, see what he's saying is increment in tensile force. So initially the tension force was equal to the gravitational force. The increment in tension force equal to mass of the rod into acceleration of the rod in upward direction. So that is what we are going to find. So what we are going to find right now is the acceleration of the rod in the upward direction, which means we can say here A is nothing but equal to y double dot. Okay, A is nothing but equal to y double dot. Okay, next, so the length of the string is constant, right? So initially if this has gone up by y, what is this length? Tell me. This will be L minus y. Okay, I'm just marking this here. This will be L minus y. So this length is L minus y plus this is x in the perpendicular direction. Okay, so vertically L minus y and perpendicular x, can we say that this is a hypotenuse? So I'll just, this is L minus y. Okay, this is x. The hypotenuse, finally the length of the string has to be the same. So I'll say that this is x. Okay, so from this triangle I can write L minus y whole square plus x square equal to L square. Okay, L minus y whole square plus x square equal to x. Now what we'll do, we'll just differentiate this expression. Okay, so we'll get this as 2, or just, I'll just take the squares fully, okay, both sides. So I'll get this as L square plus y square minus 2ly plus x square equal to L square. Okay, so L square will get cancelled. So what will I get? Y square plus x square equal to 2ly. Okay, see, we just need to find out what is y double dot, or d square y by dt square is what we need to find out. So that's it. So after we have just done this, if we differentiate this twice, we will get what is y double dot. Okay, and one more thing we discussed, that we need to find the acceleration when the rod is at the bottommost position. So what can we write? Y almost equal to 0. Okay, and x is almost equal to 0. Okay, what is the speed? We discussed that the speed y dot must be equal to 0 at this instant when it is at the bottommost point. Okay, what is x dot? Tell me. That is the speed of this point. What will be the speed of this point when it is the bottommost position? It will be this length into omega, right? So what is this length? Tell me. This is capital L. This is capital L by 2 times omega. So x dot will be capital L by 2 times omega. Okay, so now let us just differentiate this. So what will we get? 2y y dot plus x dot equal to 2l y dot. Okay, next let us move forward. I'll just cancel out this 3 places. Now if we differentiate this again, we'll get y dot square plus y double dot y plus x double dot x equal to l y dot. So again I'm differentiating, y dot becomes d square y by dt square. Okay, now I'll just take this, what is x and y both are equal to 0. So x is almost equal to 0, so we can say that this is 0. Okay, next y dot is 0, so we can say this term is also 0. Okay, and if I just take this side, I'll get see, y is very small, so compared to L we can neglect this y. Okay, so what will we get? Tell me finally. Y double dot equal to x dot square by L. And what is this x dot from here? L square omega square by 4. Okay, so L square omega square by 4 times L. Okay, so the acceleration of this rod in the vertical direction is capital L square omega square by 4 into small l. Now that's it. Once we have got y double dot, we just put it here. Okay. If we put this here, what will we get? Tell me. Tension T equal to ma by 2. So m omega square L square by 8 times L. Okay. So this is the extra tension apart from mg. It would have been the total tension. If we find, it will be mg by 2 plus this part. Okay, so he's asking what is that extra tension. Okay. So yes, this is the awesome, simple, intuitive solution. I hope you like, the solution and the visuals. Okay, and see you all in the next video.